Hello, today we're going to talk about how Dynamo deals with inputs. And to understand why this is an interesting problem, we have a very simple example to go through. So here we have an init module with a single parameter x, and then the for each function we have a single tensor y, and then we add x to y and then we return. And here we just have the runner code where we compile the model and we invoke it. Now, when we run this, we'll see that Dynamo actually creates a compiled function that looks slightly different from the forward function on the init module. In particular, Dynamo will hoist the parameter as an input to the function. And then torch.compile will actually replace the forward function with this compiled forward function, which leads us to the question of how do we make it such that when we invoke the forward function, this replace forward function, how can we make it such that the order of the inputs is correct? Because typically you will only invoke the forward with the additional inputs and not the parameters. So that's what we're going to look into today. So I'm going to quickly speed through some of this stuff because it's not too relevant, but at a high level, right, when Dynamo is tracing out a graph, what it's doing is it's doing bytecode interpretation. And the way that it does it is for all inputs or values, it will wrap it in what's called a variable tracker. And one of the most common variable trackers is this tensor variable tracker, tensor variable. And so the basic idea is that as Dynamo is tracing through the bytecode, it will use these variable trackers to represent values. And then as you call functions on these values, the variable trackers define how to create more variable trackers from the ones that you have. So for example, if you have a variable tracker for a tensor and you call .add on it, in the tensor variable tracker, we will define a call method function, and that will tell Dynamo precisely how to create a new variable tracker given that you call add with some arguments, which are oftentimes also variable trackers. A variable tracker oftentimes will wrap a proxy. We're not going to talk too much about proxies, but they're just this affordance that makes it easier to write graph passes. And a proxy wraps a node. And a node is just a node in the computation graph that we're constructing. And the basic idea is whenever we have an argument that we want to hoist as an input to the graph, we will set on the metadata field of this node this key called graph arg. And as part of this key, we set it to this class graph, an object graph arg that has a source and a value. And when we generate the code, when we do the code gen, we will do the following. So the first thing we do is we say we're going to put the compiled function onto the stack. And then for each arg in the graph args, we're going to call reconstruct. And what reconstruct does is it will emit the bytecode necessary to reconstruct this argument onto the stack. So for example, if you have self.parameters at x, it will load self, it will then get adder of parameters, and then it will get x. And so at the end of these like bytecode instructions, now you have x. And then similarly, you do the same thing for y. And after all of this is done, your stack will have the compiled function on the bottom, and then all of the arguments you need to invoke your compiled function on top, and then you invoke your function. And that's how it works. And then going back to this thing, graph args here is actually just a property method on output code. And what this property method does is it goes through placeholders and it returns this node meta graph arg that we saw up here. And what is placeholders? Placeholders is also a property method that just goes through the graph and finds all the placeholder nodes, which are the input nodes. So yeah, hopefully this was useful. It took me a while to kind of understand that this is kind of what was going on behind the scenes. Actually, before we end, why don't we look at the code? So if we run this example, we'll see that we will break point here in wrap tensor. And wrap tensor is how we typically construct a variable tracker for a tensor. And so you see here the graph arg. If you go up here, you can see the tensor proxy getting created. Oops, sorry, tensor proxy getting created up here. This wrap fx proxy creates the variable tracker, et cetera, et cetera. And then if we go through longer, so this is for y. Previously that was for x, this is for y. And then if we go a little bit longer, eventually we'll get to the code gen portion, and then I can point out exactly the code that we're talking about earlier. Here, so in PyCodeGen make generated code, you'll see here at the top, we first push the compiled function onto the stack. We then get the graph args from the output code, and then we go through each of the graph args and we call reconstruct, and then at the very end we call the function. So yeah, hopefully this was interesting, and I will see you in the next one.